Hello everyone, welcome to this video. In this video, we are going to solve the previous year questions which were asked in ISRO 2020 exam of mechanical engineering, and we will focus on the engineering mechanics and theory of machine subjects. There are a total 14 questions asked in this paper. Let's solve them one by one. Coming towards the first question of this paper. In a 4-bar linkage, if S is the length of shortest link, L is the length of longest link, and P and Q are the lengths of other links, then criteria for getting triple rocker mechanism in which no links will fully rotate is. So what they are saying is, like, we have a mechanism in which 4 links are there. Yeah, maybe like this. And link number 1, 2, 3, and 4. One of them is the longest link. Let's call this as a longest link. This one is the shortest, and the other two are P and Q. In this kind of mechanisms, we know the Grashof law says that a 4-bar linkage has at least one revolving link if length of largest plus shortest is less than other two. Okay, and this we can also call it as a class 1 type of mechanism. However, if length of the shortest and longest is greater than other two, then we cannot have the possibility of a link which can fully rotate. And in this situation, we will end up with the mechanism which will be a rocker-rocker mechanism. Hence, the option in this case is the option D. Okay. And we can call this kind of mechanism as class 2 mechanism. Coming towards the next question. Okay, we have a next question. The piston of an piston of an engine moves with a simple harmonic motion. The crank rotates at 120 RPM with a stroke of 2 meters. The velocity of the piston is asked when it is at a distance of 0.8 meters from the center. So in this case, first of all, let's analyze the given data. In the given data, the stroke is given as 2 meters. We know the stroke of the slider crank mechanism is 2R. So we can say 2R is equal to 2 meter. This implies the crank radius is given as 1 meter indirectly. Also, the crank rotates at 120 RPM. Omega is given in terms of RPM. We know that omega is 2 pi n divided by 60. So it will so it will be 2 pi into 120 divided by 60. You can write it as a 4 times pi. Answer is in terms of pi, so let's keep it in terms of pi. No need to calculate it in detail. And we also know that the velocity of piston is given by formula omega under root of r square minus x square, where r denotes the crank radius and x denotes the distance of the piston from the center. Okay, from its center. Then using this formula, we can get that omega is equal to 4 pi under root of 1 minus 0.8 square. R is 1, 1 square is 1. So it's like 1 square minus 0.8 square. And yeah, if we solve this, we'll end up with a 2.4 times pi. Okay, hence option B is correct in this case. Coming towards the next question. Okay, this is from the release component of the acceleration mechanisms, and yeah, it's from the velocity and acceleration topic of Tom. We have a block which slides outward on a link at a uniform rate of 30 meters per second. So sliding velocity of block is given, while the link is rotating at a constant angular velocity of 50 radian per second counterclockwise. The co-release component of the acceleration is what they have asked. So we know that whenever we have a turn slide pair, like we have a link on which we have a slider, it has some velocity of the slider, and which is, let's say, going away, that is outward they have mentioned. Also, the crank is rotating in counterclockwise direction they have mentioned, which is 50 radian per second. And this one is 30 meters per second. We know that whenever this kind of arrangement is there, then the co-release component of the acceleration will come because of the combination of the translation of the slider and the rotation of the link. And the co-release component of the acceleration is in the direction of, okay, we have to rotate the linear velocity vector in the direction of the angular velocity vector by 90 degree. So if we rotate this line by 90 degree in counterclockwise direction, this is of our co-release component of the acceleration. We are rotating by 90 degree the linear component of the acceleration in the direction of the angular velocity, and this co-release component of the acceleration is given by 2 into v into omega, and in this case, yeah, 2 is constant, v velocity of the slider is 30, omega is given as 50. All the units are in standard format, so we can directly put the answer. We can directly put the values and get the answer. So you will get it as 3000 meter per second square. Hence option C is correct in this case. Coming towards the next question. When the axis of the first and last gear are coaxial, then the gear train is known as. The gear train in which we have the first axis, first gear and last gear coaxial, we call it as a reverted gear train. Let me show you the arrangement. So we have a first gear, then we have, let's say, this one is the second gear. This is our input shaft. Gear number A, gear number B is then connected with the, let's say, another gear C. So this is a compound gear, and the axis of the first gear is this. It is exactly matching with the axis of the gear D, and this is our output shaft. So basically, reverted gear train is a compound gear train. However, the first and last gear are coaxial, and hence the name for this kind of gear train is a reverted gear train. Yeah, in this gear train, the center distance between the first and second gear is equal to the center distance in between the third and fourth gear. Coming towards the next question. This is from the gyroscope topic. A disk is spinning on its axis at omega 20 radian per second. Omega is given. Will undergo precision when the torque 100 Newton meter is applied. So the torque applied torque is given. That is equal to 100 Newton meter about an axis normal to it. If the mass moment of inertia is 1 kg meter square. Then the angular velocity of precision, they are asking us the omega p. We know that the gyroscopic torque, okay, let's say the reactive torque is causing the gyroscopic effect, and that will be equal to the applied torque. Hence, we can say that this 100 Newton meter has to be equal to gyroscopic effect, which is I omega p, which is the value of I in this case is 1. Omega is given as 20. Omega p is supposed to be calculated. So 100 divided by 20 is 5. So omega p is 5 radians per second. Okay. So option B is correct in this case. Coming towards the next question. Which of the following is the absorption type dynamometer? So yeah, out of this, the correct option is option A. Prony brake dynamometer is the absorption type dynamometer, which is commonly used to measure the power output of the engine. So the option A is correct in this case. Coming towards the next question. Which of the following mechanism provides intermittent rotary motion? Yeah, I have one video here to explain you, so you can clearly see. We have two links here. The link number 1 is shown in the blue color. Link number 2 is in the green color. We are providing intermittent motion to the second link with the help of the first one. This kind of mechanism is known as Geneva mechanism. So the correct answer in this case is option B. The mechanism which provides the intermittent rotary motion is known as Geneva mechanism. Next question. This is from the mechanics. We have two steel trusses, XY and YZ, of identical size, and they support a load of 200 Newton as shown in this figure. The length of the truss is also given, 1 meter and 1 meter. What they are asking is the force in the truss XY. They are asking us the force in the truss XY. So let's try to solve it by using the free body diagram. We can clearly see that these angles are, maybe I'll use let's a blue pen here. So this, we have a one load in downward direction. We will have tension in both these trusses, right? Like this. Let's call it as a Fyx, and this is Fyz. What they are asking us to calculate is Fyx. We can clearly see that this figure is symmetric in both left hand side versus the right hand side. What we can expect is we should have the same load or same force in the trusses XY as well as the YZ. So let's start with the free body diagram on the next slide. So we have a 200 Newton force acting in downward direction. Fyz is in this direction. XY is in this direction. This angle is 30 degree. We have already mentioned that. Alternate angles are same. Okay, this is an alternate angle. So angle of Fyz with respect to horizontal is 30. Similarly, the angle of Fxy or Fyx with respect to horizontal is also 30 degree. So if it is 30, if it is a 90, I can say that this whole angle is 120. This also 120. So remaining angle also has to be 120 degrees. Figure is symmetric. So we can clearly say that fxy and fyz has to be 200, 200. And let me show you how we can confirm that by using the Levi's rule. 200 Newton is the force divided by, or using the sine rule, basically. Sine rule says that the force in this direction, in any direction, is proportional to the angle opposite to it. So angle opposite to 200 is 120 degree. So 200 Newton divided by sine of 120 has to be equal to fxy divided by sine 120 is equal to fyz is or you can also write it as fyx divided by sine 120 is equal to fyz by sine of 120. What they are asking is, yeah, we can clearly see the denominators can cancel it out, and you can clearly write fyx is equal to fyz is equal to 200 Newton. Okay, the answer is option B in this case, which is 200 Newton. Coming towards the next from the mechanics, we have a block weighing 100 Newton, and it is resting on a inclined plane with a horizontal at an angle 45. What force P is necessary to hold this body sliding down the plane? They have also given the coefficient of friction 0.2. So what they are mentioning is, if we are not allowing this body, if you are not applying this force, the body can come down. However, we want to hold this body. That's why we are applying this load P, and they are asking us to calculate the same. So this is the free body diagram. 100 Newton is the weight which is acting downwards. Okay. Then the normal reaction is always perpendicular to the surface. The weight component is W sine theta, and the weight component in this direction is W cos theta. We have load P applied in this direction. It has two components. One is this, and one is in downward. The downward direction it is P sine theta, and in rightward direction it is P cos theta. All the angles are 45, so theta is 45 in this case. So first of all, what we'll do is summation of all the vertical forces is equal to 0 by applying the equations of the equilibrium. So we can say that the upward force N has to be equal to the downward forces, that is P sine of 45 plus W cos of 45. So let's write it as equation number 1. Similarly, we can write summation of all horizontal forces equal to 0. In this case, I have not shown the frictional force, but body is trying to slide down. So the frictional force has to be in the upward direction, that is mu into N. So the force which is on the left hand side is W sine of theta. So I can say it as 100 sine of 45. It has to be equal to the forces on the right hand side are the frictional force and P cos theta, mu N plus P cos of 45. We already know the value of N, so we can put it. N is P sine 45. So mu P sine 45 plus mu W cos 45 plus P cos of 45. W is 100. Yeah, let's keep it as here W as of now. So W terms, you can take it on the left hand side. So W is 100, 100 sine 45 minus mu is 0.25 they have given. So 0.25 multiplied by 100 is 25 cos of 45, and that has to be equal to P cos of 45 plus 0.25 is the mu value, P sine of 45. Now if you put the value, 1 by root 2 is the value for sine of 45, and that is also the value of cos of 45. So 100 divided by root 2 minus 25 divided by root 2 is equal to, from here it is 1 by root 2, you can take common, and 1.25 is what you can write. So from the both the sides, you can cancel out the root 2 in the denominator. So what we'll end up with is the P equal to 60 Newton. Okay, because it's a 100 minus 25, you will end up with the 75. And yeah, so okay, maybe I'll write it in detail here. 75 is equal to 1.25 times P. This implies P is equal to 60 Newton. Hence, option C is correct in this case. Coming towards the next question. This is from the vibrations. A machine component of 90 kg mass needs to be held in the position using 3 springs as shown in figure. K1, K2, and K3 are the stiffnesses. The spring constants are given to us, and the value of them is 4, 4, and 8 Newton per meter respectively. Find the natural frequency of the system in radian per second. K1 is given as 4 Newton per meter. K2 is given as 4 Newton per meter, and K3 is given as 8 Newton per meter. At this point, it is clear that K1 and K2 are in the series. Whenever two springs are in series, 1 upon K equivalent, it can be written as 1 upon K1 plus 1 upon K2, which is equal to 1 upon 4 plus 1 upon 4, which is equal to 2 upon 4. So K equivalent is equal to 2 Newton per meter. So basically, our arrangement was like this. And now what we are doing is, this is our K1, K2, K3. We are replacing K with a K equivalent, and overall figure is now looking like this. K3, then we have the mass, and then K equivalent of 1 and 2. Okay. So this is like, I'll directly write, which is 2 Newton per meter. Okay, it is, yeah, it was 2, and this is 8. This is 8 Newton per meter. So K3 is equal to 8 Newton per meter, and this is our 2 Newton per meter. So now this 8 Newton per meter stiffness spring and the 2 Newton per meter stiffness spring are in parallel with each other. Okay? Because whatever is the deflection, we can see in the, if it is getting compressed, if this K equivalent is getting compressed by a certain amount, K3 is getting tension in the same amount. Okay, so basically the deflection in both of them is same, hence those are in parallel, and we can say that now the equivalent of both of them is now equal to K3 plus this is K equivalent 1, I would say, and K equivalent, and that is 8 plus 2, that is equal to 10. So overall equivalent spring stiffness is 10 Newton per meter. Mass is also given as 90 kgs. So we know that omega, which is frequency, is root K by M. Equivalent spring stiffness is, so this is K equivalent 1, which is 10 divided by 90. And if you calculate it, you will end up with 0.33 radian per second. So the option A is correct in this case. Okay. Radian per second. If they ask in hertz, you have to use the formula again. Omega is equal to 2 pi n, and From that, you can calculate in hertz. Coming towards next question. Yeah, this is again from the vibration topic. A driver of mass 100 kgs is standing at the tip of the springboard of negligible mass. The natural frequency of the springboard with the driver is given as 1.6 hertz. So frequency f is 1.6 hertz, and omega is equal to 2 pi f, we know, okay, or 2 pi n also we can say. So from this we can say that it is 2 pi into 1.6, which is 3.2 pi radian per second. So this is the first part of the question which they have given. What they are asking is what is the static deflection at the tip of the springboard when the driver is standing at the tip? We know that if frequency is given, frequency of the springboard can be, let's say, denoted as under root of g by delta, where g is the acceleration due to gravity, and we have delta, which is called as a static deflection here. So if you use this formula, omega is already given, which was in hertz, and we have converted it into the radian per second. So it is 3.2 pi is equal to under root of g divided by delta. From this formula or from this equation, you can calculate the delta. So it's a 3.2. You can first of all do the square on both the sides, and yeah, solve it. So squaring both the sides, so roughly you will end up with this number as 100, and yeah, so 100 is equal to g by delta, more or less 101 something you will get, and then delta. Okay, so I'll explain you. This is close to 100 is equal to 100 delta is equal to 9.81 you will get, and then delta is equal to 9.81 divided by 100. Whatever you'll get is in meters. However, if you multiply with 1,000, you will get in millimeter. So these two digits will go. Hence, the answer is 98.1. Okay. The correct option is option C in this case. Coming toward the next question. Yeah, again, this question is from the vibrations topic. In a vibration isolation, if omega by omega n is less than √2, then transmissibility is. We know the transmittivity ratio, or transmittivity is force transmitted divided by the applied force. And if omega by omega n is, this is the frequency ratio we can say, and if it is equal to √2, for irrespective of any value of the damping factor zeta, transmission ratio is 1, and after that it reduces, okay, as we crosses the frequency ratio of √2. However, if the omega by omega 2 is less than √2, we can clearly see the transmittivity ratio is always, so this is the region basically, it is always greater than 1, right? Because this is the case where it is 1. And if we are talking about all the points of omega by omega n less than √2, we can clearly see the transmittivity ratio is always greater than 1. So this is how the variation we can see in the transmittivity ratio versus the frequency ratio. Hence, the option is option C in this case, greater than 1. Coming towards the next question. This is again from the vibration, the natural frequency of the simply supported beam of length L with mass m at its center and the flexural rigidity is EI. Okay, this is what they are asking. Natural frequency of we know the simply supported beam looks something like this. One end is hinged, another end is roller, and we have one mass which is m. So weight will be mg acting at the center. We know that whenever we are applying a certain weight at the center point of a simply supported beam, it will deflect. And the deflection in this case is delta is equal to WL cube divided by 40 ATI. So we can write it as W is mg, L cube divided by 40 ATI, where L is the length of the beam, mg is the weight which is kept at the center, and EI is the flexural rigidity. And we already know the formula omega n is equal to under root g by delta. G is acceleration due to gravity, delta is we have just calculated, mgl cube divided by 40 ATI. We can clearly see that gg will get cancelled. So under root of 48 EI divided by ml cube is what we can say the omega n. However, yeah, it is in terms of the, it is not in radian per second, because 1/2 pi is there in the all options. You know that omega is equal to 2 pi into frequency. So frequency in hertz is 1/2 pi times the omega, which is in radian. So the answer is 1/2 pi under root of 48 EI divided by ml cube. Okay, 1/2 pi under root of 48 EI divided by ml cube. So the option A is correct in this case. Coming towards the next question. This question is again from the vibrations topic. A machine component of natural frequency 20 radian per second. Omega n is given 20 radian per second. And this is subjected to the base motion from the machine, which is harmonic in nature with amplitude 3 meter per second square. So in this case, the amplitude of vibration is given as, okay, let's call it as x, or delta is 3 meter per, sorry, it's given as acceleration. Okay, acceleration 3 meters per second square, and omega is given as 10 radian per second. What is the peak amplitude of relative displacement of the component if damping is negligible? Damping is negligible means zeta, which is C by CC. C is 0 means C by CC will become 0, so zeta will become 0. Okay, that is what they are highlighting here. We know that amplitude of vibration is calculated as like this, F naught by S. Okay, this is the static deflection divided by under root of 1 minus omega by omega n bracket square whole square plus 2 zeta omega by omega n bracket square. However, they have mentioned that the damping is negligible, hence zeta is 0. So the second part of the root will become 0. We can do some adjustments in the numerator, like for example, F naught by M I can write, and then divided by S by M I can write, because MM can get cancelled. And in denominator, we'll have 1 minus omega by omega n whole square. under root, and the square of the whole term get cancels. F naught by m is what? F is equal to ma. So this is about the acceleration. And S by m is the natural frequency square divided by 1 minus omega by omega n bracket square. A is given as 3. Natural frequency is given as 20. It's 20 square divided by 1 minus frequency is given as 10, at which it is having, divided by the natural frequency is 20. So if you simplify this, you'll end up with the 10 mm as the answer. So basically you will end it as 1 divided by 100 you will get, which is in meter. Yeah, so in terms of millimeter, it is 10 millimeter. Hence, option C is correct in this case. I hope it is clear. So that's all from this 2020 paper. Thank you all for watching this video.